Problem 9.118a says the molar diagram on figure A-8E determine the water vapor at 500 pounds force per inches squared, 600 degrees Fahrenheit, and 1,000 feet per second. We are asked to evaluate the stagnation enthalpy in BTU per pound. The molar diagram on figure 8-8E is a diagram in which shows the enthalpy-entropy diagram for water. This diagram has an entirely different shape than the TS diagrams. It contains constant temperature lines, a series of constant pressure lines, constant quality lines, and constant superheated lines. This diagram is only used when the quality is greater than 50% and for superheated steam. Just to give you a little background on stagnation state properties, when working with compressible flows, it is more convenient to work with properties evaluated at the reference state, which is known as the stagnation state. This often might be used in diffusers operating at steady state. The energy balance for the diffuser shows that the enthalpy at stagnation state associated with the actual state in the flow, where the specific enthalpy is H and the velocity is given by H, which at stagnation state equals the enthalpy plus V squared over 2. The problem states the water vapor pressure is equal to 500 pound force over inches squared. The temperature is at 600 degrees Fahrenheit, and the velocity is equal to 1,000 feet per second. We can now use H at the stagnation state equals to the enthalpy plus V squared divided by 2. We find the value of H to be 1,298 BTU per pound. We plug in H right here and the velocity of 1,000 feet per second. We have to make sure the units work out properly by multiplying 1 pound force divided by 32.2 pound-foot over second squared, and also one more conversion, which is multiplied by 1 BTU over 778 foot times pound force. Once we substitute these values and check for the cancellation of units, our enthalpy at stagnation state is 1,317.955505 BTU per pound. And once again, just to check for the correct number of sig figs, it reduces to 1,318 BTU per pound.